1. Unit 1. Thinking Geographically. 1. Introduction to maps and types of maps. Reference: thematic, topographic, choropleth, dot, proportional symbol, isolane. Why maps are the language of geography. Let's start with something that might seem obvious, but is actually one of the most important things you'll carry into your AP exam. Maps are not just pretty pictures. Maps are arguments. Every map makes choices what to show, what to leave out, how to project a three-dimensional sphere onto a flat surface, and those choices shape how we understand the world. Think of it this way. If someone hands you a map of a city that shows every Starbucks but no hospitals, that map is telling you something very specific about priorities. The College Board wants you to think about maps the way a geographer does, as tools with purposes, limitations, and embedded perspectives. Maps generally fall into two broad families you absolutely need to distinguish: reference maps and thematic map. Get comfortable with this distinction because the exam loves to test whether you know which type of map is appropriate for a given purpose. Reference maps. The where is it? Family. Reference maps show you the physical and political features of the world. They answer the question, where is this, without trying to make an argument about data. Think of a road atlas your grandparents kept in the glove compartment, or the map on the back of a restaurant placemat. Political maps showing country borders and capital cities are reference maps. Physical maps showing mountain ranges and rivers are reference maps. Topographic maps fall into this family as well, and they deserve special attention. A topographic map shows elevation using contour lines, curved lines that connect all points at the same elevation above sea level. Imagine slicing a mountain horizontally, like cutting layers through a loaf of bread, and then looking down from above at each slice. Each line you'd see is a contour line. On the AP exam, you need to know several key rules about reading these. Contour lines never cross each other, because a single point cannot be at two different elevations simultaneously. When contour lines are packed closely together, the terrain is steep. When they're spread far apart, the terrain is gentle or flat. And V-shaped contour lines pointing uphill indicate a valley or stream, while V-shapes pointing downhill indicate a ridge. The interval between labeled contour lines is called the contour interval, and every map will state it clearly in the legend. If the contour interval is 50 feet and you count 3 lines between 2 labeled lines, you know you've climbed 150 feet. The exam occasionally gives you a topographic map and asks you to interpret landforms or explain why a settlement formed in a particular location, so practice reading these until the shapes become intuitive. Thematic maps. The What's Going On Here family. Thematic maps are where things get really interesting for AP Human Geography, because they're the ones geographers use to show patterns, distributions, and spatial relationships. You have 4 major types to master: choropleth, dot, proportional symbol, and isolane maps. Each one communicates data differently, and the exam will ask you both to interpret them and to recognize when one is more appropriate than another. Choropleth maps use shading or color variation to show data across predefined areas, usually countries, states, or counties. You've seen these when election results get mapped with states shaded red or blue, or when a world map shows income levels with darker colors representing wealthier nations. Here's the critical conceptual point. Choropleth maps assume that whatever value they're showing is uniform across the entire shaded unit. A state shaded to represent an average income of $60,000 looks the same everywhere inside its borders, even though in reality some cities in that state have incomes twice as high. This is a massive limitation called the modifiable areal unit problem. The pattern you see can change dramatically depending on how the boundaries are drawn. The AP exam loves to ask about limitations of maps, and this is the most important limitation of choropleth maps to have ready. Dot maps use individual dots to show where something actually occurs in geographic space. One dot might represent 1,000 people, or 500 farms, or 50 schools. The map's legend tells you the value per dot. The power of a dot map is that it preserves spatial variation that a choropleth would flatten away. A dot map of U.S. population would show dense clusters in New York and Los Angeles and sparse dots across the Great Plains, giving you a much more honest sense of where people actually live. The trap students fall into on MCQs is confusing dot density with absolute data values. A region with few dots isn't necessarily unimportant. It might just cover a large area. Always read the dot value in the legend before drawing conclusions. Proportional symbol maps, also called graduated symbol maps, use symbols, circles, squares, triangles, whose size is scaled proportionally to the value they represent. A city with a population of 10 million gets a circle 10 times the area of a city with 1 million people. These are excellent for showing totals or absolute quantities. Notice the distinction from choropleth. Choropleth typically shows rates or percentages, income per capita, percentage of population in poverty, while proportional symbol maps tend to show raw totals, total population, total exports. This is a classic MCQ trap. The exam will describe a dataset and ask which map type is most appropriate, and you need to recognize that rates go to choropleth while totals go to proportional symbols. Isoline maps use lines connecting points of equal value, just like topographic maps use contour lines for elevation. But isoline maps can represent any continuous variable across space: temperature, precipitation, air pressure, or even commute times. Weather maps showing isobars, lines of equal atmospheric pressure, or isotherms, lines of equal temperature, are isoline maps. The key interpretive rule mirrors topographic maps. Lines close together mean rapid change across space. Lines spread apart mean gradual change. On an isoline map of annual rainfall, tightly packed lines along a mountain range would indicate that rainfall drops off sharply over a short distance. Common exam traps and connections to watch for. The single most common mistake students make is using the terms reference and thematic imprecisely, or assuming all maps with data are thematic. Remember, a map can show data and still be primarily a reference map if its purpose is locating features, rather than revealing spatial patterns. Also watch out for questions that ask about map distortion. Any time a flat map represents the curved Earth, something gets distorted, whether area, shape, distance, or direction. This connects directly to your next subtopic on map projections, where distortion becomes the central conversation. Understanding map types also weaves through every single unit in this course. When you study population distribution in Unit 2, you'll use dot and choropleth map. When you analyze agricultural regions in Unit 5, you'll interpret thematic maps constantly. When you look at economic development in Unit 7, choropleth maps comparing GDP per capita will be your primary tool. Maps aren't just Unit 1 content, they're the vocabulary of the entire course. With the map types firmly in your toolkit, we're ready to turn to the fundamental question underneath all of them. How do we even get from a round planet to a flat page? And what do we lose in that translation? 1.2 Map projections and distortion. Mercator, Peters, equal area, distortion of shape, area, distance, direction. The fundamental problem, peeling an orange. Here's a thought experiment that will stick with you forever. Grab an orange, peel it in one piece, and then try to flatten that peel completely on a table. What happens? It tears, it warps, it buckles. That right there is the core problem of cartography, and it's the heart of everything you need to know about map projections for the AP exam. The Earth is a sphere, a map is flat. You cannot convert one to the other without distortion. No map, not a single one ever made, is perfect. Every map lies to you in at least one way. The critical question, the one the College Board wants you to think about deeply, is which kind of lie does this map tell, and why did the mapmaker choose that particular lie? That question will get you points on both the multiple choice and the free response. The 4 properties: shape, area, distance, direction. Every map projection distorts at least one of 4 spatial properties, and you need to know all 4 cold. Shape refers to whether the outlines of land masses look correct. Are the angles between features preserved? A projection that preserves shape is called conformal. Area refers to whether regions are shown in correct proportion to one another. Does Greenland actually look as big as it really is relative to Africa? A projection that preserves area is called equal area, or sometimes equivalent. Distance refers to whether measurements between points on the map reflect true distances on the ground. and direction refers to whether compass bearings are accurate. A projection preserving direction is called azimuthal. No projection preserves all four simultaneously. That's not a design flaw. It's a mathematical impossibility. When one property is preserved, others must be sacrificed. The Mercator projection, the map you grew up with. The Mercator projection, developed by Flemish cartographer Gerardus Mercator in 1569, is probably the map you stared at on your elementary school classroom wall. Mercator's genius was that he created a conformal projection. It preserves shape and direction beautifully. If you draw a straight line between 2 points on a Mercator map, that line represents a constant compass bearing, which sailors call a room line. For 16th century navigation across oceans, this was revolutionary. You could plot your course with a ruler and a compass and actually get where you were going. That's why Mercator built the map, and that purpose matters for the exam. But here is the distortion Mercator's map introduces, and this is where students lose points. It dramatically distorts area, especially near the poles. To make those straight navigational lines work mathematically, Mercator had to stretch land masses horizontally and vertically as you move away from the equator. The result is that Greenland appears roughly the same size as Africa on a Mercator map. In reality, Africa is about 14 times larger than Greenland. Alaska looks bigger than Brazil. Europe appears inflated relative to sub-Saharan Africa. This isn't an accident. It's a direct consequence of preserving direction and shape. The AP exam loves to ask you to identify this specific distortion and explain its consequences. The political critique of the Mercator projection is also fair game. By inflating the size of high-latitude nations, which include much of Europe, North America, and Russia, and compressing equatorial regions in Africa, South America, and Southeast Asia, the Mercator map has been criticized for subtly reinforcing a Eurocentric worldview. Whether or not that was Mercator's intent, the College Board expects you to understand the connection between map design choices and political or cultural implications. The Peters projection and equal area maps. In 1973, German historian Arno Peters introduced a projection he claimed would correct the Mercator's biases. The Peters projection, more precisely called the Gall-Peters projection because James Gall had developed a nearly identical version a century earlier, is an equal area projection. It preserves the relative sizes of all land masses faithfully. Africa and South America appear enormous, as they actually are. Greenland shrinks to its true proportional size. The Peters map was embraced by development organizations and activists, who argued it gave an accurate sense of the scale of the global South. But preserving area means sacrificing shape. On the Peters projection, continents and countries look stretched and distorted, squashed near the equator, and elongated toward the poles. Scandinavia looks like a pulled piece of taffy. Geographers debated fiercely whether Peters had simply replaced one set of lies with another. The key AP exam insight here is this: Peters and Mercator represent a trade-off, not a progression from wrong to right. Each serves a different purpose. Mercator's better for navigation. Peters is better for comparing the geographic size of regions. When you see an FRQ asking you to evaluate which projection is appropriate for a given task, anchor your answer in purpose and which property matters most for that use. Other projections worth knowing. The AP exam may also reference the Robinson projection, a compromise projection used by National Geographic for decades. It doesn't perfectly preserve shape or area, but minimizes overall distortion across both, making it visually appealing for general reference maps. The Winkle triple projection has since replaced it at National Geographic for similar reasons. You should know that azimuthal projections preserve direction from a central point and are useful for air navigation, while conic projections are often used for mid-latitude regions and perform reasonably well for both shape and area within a limited zone. The MCQ trap you must avoid. Here is the single most common wrong answer trap. Students see a distorted-looking map and immediately assume something is wrong with it, or that it's a bad map. The College Board will offer you answer choices that frame map projections as correct or incorrect. Resist that framing entirely. Every projection is correct for its intended purpose. The question to ask is always, what property does this projection preserve, and is that the right property for this application? A map designed for equal area comparison is not failing when shapes look stretched. It's succeeding at its actual job. Also watch out for questions that conflate scale with projection. Scale is the ratio of map distance to real-world distance, and it's a separate concept. Distortion from projection is not the same as choosing a large-scale versus small-scale map, and mixing those up will cost you points. Connecting to the bigger picture. Map projections connect directly to later units in this course. In Unit 2, when you study population distribution and density, the map you're reading determines whether those visual impressions are accurate. In Unit 7, when you examine development and the divide between the global north and global south, understanding that the Mercator projection inflates wealthy, high-latitude countries adds a crucial layer of critical analysis. Every time you encounter a thematic map, a choropleth, a dot map, a cartogram, the projection underneath shapes what you see. With a firm grasp on how maps distort and why, you're ready to move into the next essential tool geographers use to understand the world. The different types of maps themselves, from reference maps to thematic maps, and how each is designed to communicate a specific kind of geographic story. 1.3 Geographic Data and Spatial Concepts. Let's talk about how geographers actually do geography, because everything in this course depends on understanding how we collect, represent, and analyze information about the world. Think of this section as learning the toolbox. Once you know what's in it, the rest of the course becomes so much cleaner and more intuitive. Types of geographic data. Start with the fundamental question: where does geographic data come from? Geographers work with two main categories. Primary data is collected firsthand. You go out, you observe, you count, you survey. A researcher walking through a neighborhood counting the number of chain restaurants versus locally owned ones is generating primary data. Secondary data is gathered from existing sources, census records, satellite imagery archives, historical map. The AP exam occasionally tries to blur this line. So remember, if someone else already collected and published it, it's secondary, even if you're using it in a brand new study. Within those categories, data can be qualitative or quantitative. Qualitative data captures qualities, descriptions, categories, cultural meanings, interview responses. Quantitative data captures quantities, numbers, measurements, counts. A geographer recording the ethnic makeup of a neighborhood in descriptive terms is working qualitatively. 1. Counting the percentage of residents who identify with each ethnicity is working quantitatively. Both are valid and powerful, and the exam will ask you to distinguish between them in context. Spatial concepts. You must know cold. Here's where geography gets its identity. The term spatial simply means relating to space, the location, distribution, and arrangement of things across Earth's surface. The AP exam is saturated with spatial thinking, so let's walk through the core concepts you'll need. Location comes in two flavors. Absolute location is a fixed mathematical position on Earth, a GPS coordinate, a street address, a latitude and longitude reading. 40.7128 degrees north, 74.0060 degrees west is the absolute location of New York City. It never changes. Relative location describes a place in relation to other places. New York City is northeast of Philadelphia, about a 2-hour drive from the coast of New Jersey. Relative location changes depending on your reference point and can convey cultural, economic, and political meaning that absolute location alone can't capture. The exam loves asking you to distinguish these. Remember, relative is about relationships, not coordinates. Scale is one of the trickiest concepts for students to internalize, but here's an analogy that might help. Think of looking at a map of the entire world versus a map of your city block. The world map shows you big patterns, but leaves out local detail. The city block map gives you enormous detail, but tells you nothing about the global picture. When geographers talk about local scale, they mean small areas with lots of detail. Regional scale zooms out to cover areas like the American South or Sub-Saharan Africa. Global scale zooms out to the entire planet. Here's the MCQ trap that gets students every time. A larger scale in geographic terms means you're covering a smaller area with more detail. A large-scale map of Paris shows individual streets. A small-scale map of Europe shows only country outlines. This is counterintuitive. Students constantly flip it. So say it out loud. Large scale, small area, more detail, space and place sound interchangeable but aren't. Space is the abstract, geometric container, just a location without meaning. Place is space imbued with human meaning, identity, and experience. Times Square is a space in the sense that it occupies measurable coordinates in Manhattan, but it's a place because millions of people attach memories, meanings, and cultural significance to it. This distinction matters enormously in Unit 2 when you explore cultural landscapes and sense of place. Geographic data tools, GIS, GPS, and remote sensing. Now let's open that toolbox fully. The exam expects you to understand 3 major tools: GIS, GPS, and remote sensing. Geographic Information Systems, GIS, are computer-based systems that capture, store, analyze, and display spatial data. Imagine layering transparencies on an overhead projector. One layer shows roads, another shows elevation, another shows population density. GIS does this digitally, allowing analysts to ask questions like, where do areas of high poverty overlap with areas of poor air quality? This is powerful precisely because it reveals patterns that no single data layer could show alone. When the AP exam asks about GIS, think layering, analysis, decision-making. Global positioning systems, GPS, use satellite triangulation to determine absolute location on Earth's surface. Your phone uses GPS every time you open a Maps app. For the exam, GPS is primarily a tool for collecting precise location data. It's the input that feeds into GIS. Remote sensing involves collecting data from a distance, typically using satellites or aircraft equipped with sensors. Satellite imagery, aerial photography, and thermal imaging are all forms of remote sensing. A geographer monitoring deforestation in the Amazon doesn't have to physically walk through every square mile. Satellites collect the data. The key distinction the exam tests: remote sensing collects data, GIS analyzes and displays it. Students frequently confuse the two by treating them as interchangeable, but they serve fundamentally different functions. The census and quantitative spatial data. The census is one of the most important sources of secondary geographic data, and it shows up constantly in AP Human Geography. In the United States, a census is conducted every 10 years and counts population, housing, income, race, ethnicity, and dozens of other variables. Geographers use census data to map population distributions, identify demographic shifts, and analyze spatial inequality. The exam will show you census-derived maps or data tables. Your job is to read them critically, identify patterns, and connect those patterns to geographic concepts. Connecting to the rest of the course. This section might feel like vocabulary building right now, but here's what you need to understand. Everything in AP Human Geography rests on this foundation. Unit 2's cultural landscapes are analyzed using GIS. Unit 4's political boundaries are established using precise location data. Unit 7's agricultural patterns are studied through remote sensing imagery. The spatial concepts, scale, place, absolute and relative location, reappear in every single unit. When an FRQ asks you to explain how a geographic concept applies to this situation, the concepts from this section are often what's being tested, just wearing a different unit's clothing. The most common FRQ scoring mistake here is using terms loosely. College board readers are trained to look for precision. It shows where things are, will not earn credit. The GIS analysis layers population density data over infrastructure maps to identify spatial disparities will. Practice writing with that level of technical specificity. As you move into 1.4, you'll begin applying these tools and concepts directly to understanding how humans interact with the physical environment, and you'll see immediately why having this spatial vocabulary in your back pocket makes every argument sharper and every analysis more powerful. The power of geographic data. Why data is the foundation of everything geographic. Let's start with a simple truth. Geography is not just about maps and memorizing capitals. At its core, geography is a science, and like all science, it runs on data. Think of geographic data as the raw ingredients a chef needs before cooking anything. You can have the most sophisticated recipe in the world, the most elegant geographic theory, but without quality data, you're cooking with nothing. Section 1.4 is about understanding where that data comes from, how geographers collect it, and crucially, why the method of collection shapes the conclusions you can draw. For the AP exam, this section connects to nearly every unit that follows, so getting it solid now pays dividends all year long. The two fundamental types of geographic data, geographers gather information through two broad methods, and the AP exam loves to test whether you can tell them apart. The first is primary data collection, which means the geographer goes out into the world and gathers the information themselves firsthand. Imagine a researcher standing on a street corner in Sao Paulo, counting pedestrian traffic every 15 minutes. That researcher is generating primary data, original observations tied to a specific place and time. Primary data collection methods include field observation, surveys and interviews, GPS tracking, and environmental sampling. The second method is secondary data collection, which means using data that someone else already gathered, census records, satellite imagery archives, published academic datasets, historical land surveys. These are all secondary sources. Here is your first big exam trap. Students often assume that secondary data is somehow less reliable or less valuable than primary data. That is not the case. Secondary data is indispensable. It lets you study patterns across decades or continents that no single researcher could observe firsthand. The distinction is about origin, not quality. Quantitative versus qualitative. Two ways of seeing the world. Now layer another distinction on top of primary versus secondary, and you get one of the AP exam's favorite conceptual pairings. Quantitative data is numerical, counts, measurements, percentages, rates, population density in people per square kilometer, median household income in dollars, average annual rainfall in millimeters. These are all quantitative. Qualitative data is descriptive and interpretive, interview transcripts, field notes, photographs, oral histories. It captures meaning, experience, and context in ways numbers simply cannot. Here's the analogy that makes this stick. Imagine you want to understand a neighborhood. Quantitative data gives you the skeleton, population figures, average age, housing costs. Qualitative data gives you the heartbeat, what residents say about safety, how they describe their relationship to a nearby park, the stories a longtime shop owner tells about how the block has changed. For the AP exam, you need to know that geographers often use both in combination, and you should be prepared to explain why one type alone might be insufficient for a given geographic question. Geospatial technologies, the toolkit that changed everything. This is where section 1.4 gets especially exciting and especially testable. Geospatial technologies are tools that collect, process, and visualize data tied to specific locations on Earth's surface. The three you absolutely must know are GPS, GIS, and remote sensing. GPS Global Positioning System is the technology that tells you where something is, using a network of satellites to pinpoint locations with remarkable precision. You use GPS every time you open a map app on your phone. For geographers, GPS enables precise field data collection, tagging the exact coordinates of a soil sample, a wildlife sighting, or an infrastructure failure. GIS, Geographic Information Systems, is arguably the most important tool in modern geography. Think of GIS as a stack of transparent maps layered on top of each other. One layer shows elevation, another shows roads, another shows population density, another shows flood zones. GIS software lets geographers overlay these layers, analyze the relationships between them, and ask questions like, where do high population density, low elevation, and proximity to rivers all intersect? That answer might identify communities at catastrophic flood risk on the AP exam. GIS is specifically associated with spatial analysis, finding patterns and relationships by examining multiple variables across geographic space simultaneously. A common MCQ trap is to confuse GIS with simple mapping. GIS does not just display data, it analyzes it, Remote sensing refers to collecting data about Earth's surface from a distance, typically using satellites or aircraft. Satellite imagery, aerial photography, and LiDAR scans all fall under remote sensing. The key concept here is that remote sensing allows geographers to study areas that are physically inaccessible, track changes over time, and collect data at a global scale. Think about how scientists monitor Amazon deforestation rates. They are not sending someone into the rainforest with a measuring tape. They are analyzing spectral reflectance data from satellites to detect where tree cover has been lost. Why data collection method shapes your conclusions. Here's a deeper idea the AP exam tests at the conceptual level. The tool you use to collect data shapes what you can see and what you cannot. A household survey captures what people say they do, but not necessarily what they actually do. Remote sensing captures land cover but cannot capture why land use has changed. GIS analysis depends entirely on the quality of the layers you feed into it. Garbage in, garbage out. This is sometimes called the power and limits of geographic data, and it is why geographers are trained to be critical consumers of data, not just collectors of it. Connections across the course. Understanding geographic data tools is not a one-unit topic. It echoes through everything. In Unit 2, when you study population, you will work with census data and population pyramids, that is, secondary quantitative data. In Unit 4, when you examine political geography and gerrymandering, GIS is literally the tool governments use to redraw district boundaries. In Unit 7, when you analyze cities and urban land use models, remote sensing is how urban sprawl is measured over time. Anytime the exam shows you a map and asks how that map was made or what its limitations are, you are back in 1.4 territory. The exam edge, traps, and scoring points on multiple choice questions. Watch out for answer choices that overstate what a single data type can prove. No single data source gives the complete picture. That is almost always a wrong answer. On the FRQ, when you are asked to describe or explain a geographic pattern, referencing the data tool that would be used to observe that pattern earns scoring points. Mentioning GIS, remote sensing, or GPS in context, not just as dropped vocabulary, but as tools connected to a specific geographic question, demonstrates the kind of precision College Board rewards. With the tools and language of geographic data now in your toolkit, you are ready to take the next step, understanding not just how data is collected, but how it gets organized and visualized, which brings us directly into the fascinating world of geographic models and data representation. 1.5 Geospatial Technologies, GIS, GPS, Remote Sensing, Satellite Imagery, Applications and Limitations. What are geospatial technologies? All right, let's talk about the toolbox. Every geographer needs tools to collect, analyze, and display spatial information, and in the modern world, those tools are increasingly digital. The College Board groups these under the umbrella term geospatial technologies, and understanding what each one does, how they differ, and where they fall short is absolutely essential for your AP exam. Think of geospatial technologies as the instruments in an orchestra. Each one plays a different role, but together they help geographers make sense of the world. Geographic Information Systems, GIS. Start with GIS, Geographic Information Systems, because it is the most heavily tested of the bunch. A GIS is a computer-based system that captures, stores, analyzes, and displays geographic data. Here's the analogy that makes this click. Imagine stacking transparencies on an overhead projector. Each transparency shows one layer of information: roads, population density, elevation, land use, soil type. On their own, each layer tells you something useful. But when you stack them, you can see relationships that were invisible before. That is exactly what GIS does with digital data layers. Geographers call this layer analysis or overlay analysis, and it is the conceptual heart of GIS. For the AP exam, you need to know that GIS integrates both spatial data, the where, points, lines, and polygons on a map, and attribute data, the what, tables of information attached to those features. A hospital is a point, a river is a line, a county boundary is a polygon. The power of GIS is that it links geography to information, so you can ask questions like, How many people live within 2 miles of a toxic waste site, and get a mapped answer. Real-world applications include urban planning, epidemiology, environmental management, military logistics, and disaster response. When FEMA responds to a hurricane, GIS tells them where hospitals are, which roads are flooded, and which census tracts have the highest concentrations of elderly residents who need evacuation assistance. That is GIS at work. A common MCQ trap is confusing GIS with GPS. Remember, GIS is the analysis platform. GPS is a data collection tool. GPS feeds data into GIS, but they are not the same thing. If a question asks, what system allows you to analyze multiple layers of spatial data simultaneously, the answer is GIS, not GPS. Global Positioning System, GPS. GPS, the Global Positioning System, is a network of satellites maintained by the U.S. Department of Defense that allows any receiver on Earth to determine its precise location. Your phone uses it every time you open a Maps application. The system works through trilateration. Your device receives signals from at least 3 satellites, and by measuring the time delay of each signal, it calculates its distance from each satellite. Where those 3 spheres of distance overlap, that is, 4 or more satellites give you even greater accuracy, including elevation. For the AP exam, you do not need to calculate trilateration, but you do need to understand the concept and know that GPS provides real-time location data. GPS is used in precision agriculture, where farmers guide tractors to within inches, wildlife tracking, geocaching, surveying, and navigation. Its primary limitation is that it requires a clear line of sight to satellites, so it can be less accurate under dense tree canopy, inside buildings, or in deep urban canyons where tall buildings block the sky. Remote sensing. Remote sensing is the collection of data about Earth's surface from a distance, typically from aircraft or satellites, without direct physical contact. Think of it as taking a photograph of Earth from above, but far more sophisticated. Remote sensing instruments detect energy reflected or emitted from the surface, including wavelengths far beyond what the human eye can see, such as infrared, ultraviolet, and microwave radiation. Here is where it gets interesting for the exam. Different wavelengths reveal different information. Infrared imagery can distinguish healthy vegetation from stressed vegetation because living plants reflect infrared light differently than dead or dry ones. This is how scientists monitor deforestation in the Amazon. Healthy forest looks dramatically different in infrared than cleared land. Thermal imaging detects heat signatures, which is why it can be used to find heat loss in buildings or track volcanic activity. Radar remote sensing can even penetrate clouds and darkness, making it invaluable in tropical regions where cloud cover is nearly constant. The key limitation of remote sensing to memorize is resolution versus coverage. High-resolution imagery shows fine detail but covers a small area and costs more to acquire and process. Low-resolution imagery covers vast areas but misses fine details. No single image gives you everything. This trade-off appears frequently on the MCQ section. Satellite imagery. Satellite imagery is technically a product of remote sensing, but the College Board treats it as its own category, so you should too. Satellite imagery provides continuous, repeatable coverage of Earth's surface and is the backbone of how geographers monitor change over time. Google Earth, for instance, stitches together satellite imagery from multiple sources to give you that iconic bird's-eye view of your neighborhood. On the AP exam, satellite imagery questions often ask you to identify what it can and cannot tell you. It can show you land cover changes, urban expansion, agricultural patterns, glacial retreat, and coastal erosion. What it cannot easily show you is why those changes are happening. That requires additional data, fieldwork, and analysis. This is a critical distinction. Remote sensing and satellite imagery describe the spatial pattern. GIS and human interpretation help explain it. A question might show you a satellite image of a rapidly expanding city and ask what geospatial technology you would use to analyze the relationship between urban growth and proximity to transportation corridors. The answer is GIS, because you need to overlay multiple data layers and run spatial analysis, Satellite imagery alone just shows you the pattern. Connecting to other units. These tools are not just Unit 1 content, they follow you throughout the entire course. In Unit 2, population geographers use GIS to map population density and migration flows. In Unit 4, political geographers use satellite imagery to monitor border changes in conflict zones. In Unit 5, agricultural geographers rely on remote sensing to track crop yields and land degradation. Whenever you see a map in any unit, ask yourself, what geospatial technology was likely used to produce it? One final exam tip. Free response questions sometimes ask you to describe how a geographer might use geospatial technologies to study a given phenomenon. When you see that prompt, name the specific technology, explain the mechanism, layers in GIS, trilateration in GPS, wavelength detection and remote sensing, and connect it to a real limitation. That three-part structure, name, mechanism, limitation, is exactly what AP rubrics reward. With your geospatial toolkit now fully stocked, you are ready to move into the foundational geographic concepts that those tools help us study, starting with the essential question of how we describe where things are, which is exactly what we tackle in the next section on geographic scale and spatial patterns. 1.6 Spatial concepts and geographic patterns, absolute versus relative location, distance, direction, clustering, dispersal, elevation. The fundamental language of geography. All right, let's talk about the core vocabulary that geographers use to describe where things are and how they're arranged across space. Think of this section as learning the grammar of geography. Without it, nothing else in this course makes sense. And I promise you, if you get comfortable with these concepts now, you'll see them showing up everywhere. In Unit 2, when we talk about population distribution, in Unit 4, when we examine cities, and all the way through Unit 7, when we analyze economic development. These aren't isolated vocabulary words. They're the lenses you'll use to analyze almost every topic on the AP exam. Absolute versus relative location. Let's start with location because it's deceptively simple and the AP exam loves to test the distinction between its two forms. Absolute location is the precise mathematical position of a place on Earth's surface expressed using a coordinate system, most commonly latitude and longitude. When you say the Eiffel Tower is located at approximately 48.86 degrees north, 2.29 degrees east, that's an absolute location. It never changes. It doesn't depend on your perspective or on other places. That's the key. Absolute location is fixed and universal. Relative location, on the other hand, describes where something is in relation to other places. It's inherently comparative and context-dependent. Chicago is about a day's drive southwest of New York, or the coffee shop is 2 blocks north of campus. Those or relative location can shift depending on who's speaking, where they are, and even the era in which they lived before the railroads. Saying Chicago was far from the East Coast meant something very different than it does today. This is a concept called time-space compression, which you'll revisit in Unit 3 when studying globalization, so tuck that connection away. The AP exam trap here is subtle, but appears regularly. Students assume absolute location is always more useful than relative location. That's not true. A real estate agent doesn't tell you this house is at 40.71 degrees north, 74.00 degrees west. They tell you it's near good schools and a 15-minute commute from downtown. Context determines which form of location is more meaningful. Know both and know when each one is most appropriate. Distance, absolute, relative, and cognitive. Distance works the same way. Absolute distance is the exact measurement between 2 points, miles, kilometers, nautical miles, a number that doesn't change. Relative distance transforms that measurement into a more meaningful unit like time, cost, or effort. Flying from Los Angeles to New York takes about 5 hours. Driving takes several days. The absolute distance is the same, but the relative distance measured in time is dramatically different depending on mode of transportation. There's also a third type you need to know for the exam: cognitive distance, sometimes called perceived distance. This is how far a place feels in someone's mind, which doesn't always match reality. Studies show that people consistently overestimate the distance to unfamiliar places and underestimate distance to familiar ones. A college student might feel like their hometown is closer than a city that's actually fewer miles away but feels psychologically foreign. Cognitive distance becomes important in Unit 3 when you study migration and why people don't always make objectively rational decisions about where to move. Direction, absolute and relative direction, follows the same absolute versus relative framework. Absolute direction uses the cardinal and intercardinal points of a compass, north, south, east, west, and the combinations between them. These are fixed and tied to the Earth's poles. Relative direction uses culturally or contextually defined terms, up the street, inland, toward the mountains, or even cultural references like down south in American English. Be careful on the exam. When a question asks you to describe the spatial relationship between two places with precision, default to absolute direction. When a question probes human perception or cultural geography, relative direction is often the key concept. Clustering and dispersal, the heart of spatial patterns. Now we arrive at two of the most important concepts in this section, and honestly in all of AP Human Geography. Clustering, also called agglomeration in economic geography, describes the tendency of phenomena to concentrate together in space. Think about how hospitals, medical offices, and pharmacies tend to cluster together in a city, or how tech companies concentrated in Silicon Valley. Clustering happens because proximity creates advantages, shared infrastructure, labor pools, knowledge spillovers, or simply mutual attraction. Dispersal is the opposite tendency, phenomena spreading out across space, away from a central point or from each other. A population fleeing a natural disaster disperses. Invasive species spread from a point of introduction. Ideas, diseases, and cultural practices disperse through the process of diffusion, which you'll study extensively in Section 1.5 and revisit in Unit 3 and Unit 4. The key exam skill here is reading a map or data set and correctly identifying whether the pattern you're seeing represents clustering, dispersal, or a mix of both. For the FRQ, be ready to explain why a pattern exists, not just describe it. Saying factories are clustered near rivers earns a basic point. Explaining that clustering occurred because rivers provided power, water, and transportation routes, and that this pattern persisted due to path dependency even after those original advantages disappeared, earns full credit. Elevation and its spatial significance. Elevation refers to a location's height above or below sea level, measured in absolute terms, meters or feet. Don't underestimate this concept. It drives climate patterns, agricultural possibilities, settlement distribution, and transportation routes. High elevation means cooler temperatures and thinner air. It's why cities like Quito, Ecuador, despite being on the equator, have a mild, spring-like climate year-round. On the AP exam, elevation questions often appear in the context of population distribution, Unit 2. Humans tend to cluster at low to moderate elevations near water, or in the context of agricultural zones, Unit 5, where you'll learn how altitude creates distinct agricultural belts on mountain slopes. Topographic maps and cross-section diagrams are the visual tools geographers use to represent elevation. On a topographic map, contour lines connect points of equal elevation, and the closer together those lines are, the steeper the terrain. You won't necessarily be asked to draw one from scratch on the AP exam, but you absolutely must be able to read one identifying ridges, valleys, slopes, and how elevation changes across a landscape. Bringing it all together. Here's the big picture insight. College Board wants you to walk away with all of these concepts: location, distance, direction, clustering, dispersal, and elevation are tools for analyzing spatial patterns, meaning the way things are arranged across Earth's surface. Geographers don't just describe where things are, they ask why they're there and what consequences that arrangement has. Every time you see a map on the AP exam, your instinct should be to ask, what is clustering? What is dispersed? What absolute and relative locations matter here? And what role does physical geography, like elevation, play? With that spatial thinking toolkit now firmly in hand, you're ready to move into the equally fascinating question of how geographers collect, represent, and analyze all this information, Which brings us to the maps, projections, and geographic data tools you'll need to master next. 1.7 Human-Environment Interaction. Let's talk about one of the most fundamental ideas in all of human geography, the relationship between people and the planet they call home. This is the kind of topic that sounds almost philosophical at first, but by the end of this section you're going to see it everywhere. In your morning coffee, in the city you live in the news. That's the magic of human-environment interaction, and it's absolutely essential for your AP exam. The core idea, it goes both ways. The central concept here is deceptively simple. Humans and the environment influence each other. That's it. But the AP exam wants you to understand that relationship with real precision. Geographers think about this interaction in 3 specific ways, and you need to know all 3 cold. First, humans depend on the environment. We need clean water, fertile soil, breathable air, and raw materials before modern supply chains. This was obvious. Settle near a river and you eat. Ignore that relationship and you starve. Second, humans modify the environment. We dam rivers, clear forests, build cities, drain wetlands, terrace hillsides. Every time you see a landscape, ask yourself, what has a human hand changed here? Third, and this is the one students most often forget, the environment modifies us. It shapes our cultures, our economies, our settlement patterns, our architecture. The Inuit developed kayaks and igloos, not because of some cultural whim, but because the Arctic environment demanded those adaptations. Human culture is, in part, a response to physical geography. Determinism versus possibilism, the big conceptual fight. Now here's where the AP exam really wants to see your thinking. Geographers have historically argued about how much the environment controls human behavior, and this debate produced 2 major schools of thought you must be able to distinguish. Environmental determinism is the older view popularized in the late 19th and early 20th centuries by geographers like Ellsworth Huntington and Friedrich Ratzel. Determinists argued that the physical environment, climate, terrain, resources essentially dictates human behavior and societal development. The hot tropics make people lazy. The harsh northern climates produce vigorous civilizations. That was their logic. This view has been thoroughly discredited because it's both scientifically flawed and was used to justify colonialism and racism. The AP exam may present you with a scenario and ask you to identify the perspective. If a statement suggests the environment forces or determines human outcomes with no human agency involved, that's environmental determinism. Be careful. The exam sometimes disguises this in subtle language. Possibilism emerged as the corrective geographers, like Paul Vidal de la Blache, argued that the environment sets limits and presents opportunities, but humans have the agency and creativity to choose among those possibilities. The environment is the menu. Humans choose what to order. France and China both have river systems. One developed wine culture, one developed rice agriculture. The rivers didn't dictate a single outcome. People made choices within the possibilities their environment offered. On the AP exam, if a scenario emphasizes human choice, technology, or cultural adaptation within environmental constraints, that's possibilism. The word possibilities embedded in the term is your memory anchor, a common MCQ trap. Students confuse humans modifying the environment with environmental determinism. Modifying the environment is just an example of human-environment interaction. It's actually evidence of possibilism because it shows human agency overcoming environmental limits. Don't mix those up. Political ecology and scale. The AP exam also expects you to think about power when analyzing human-environment interaction. Political ecology is the framework that asks, who benefits from how the environment is used and who bears the costs? Think about a logging company that clears a rainforest. The company and its shareholders profit, the indigenous community that depended on that forest, and the global climate bear the cost. This unequal relationship, often structured by wealth, race, and political power, is what political ecology examines. Expect FRQ questions that ask you to evaluate the impacts of resource extraction or land use on different groups, and make sure you're identifying those power dynamics explicitly. Scale matters enormously here. What looks like a rational agricultural decision at the local farm scale may contribute to regional desertification and global climate change at larger scales. The AP exam loves to test whether you can shift scales and recognize that an interaction has different meanings and consequences depending on the geographic level you're analyzing. The big models and real-world examples you need. Several models and real-world cases appear repeatedly on the exam. The RLC is the canonical example of catastrophic human modification. Soviet irrigation projects diverted the rivers feeding this once enormous lake in Central Asia, and it shrank to a fraction of its original size, collapsing fisheries and local economies and leaving fishing boats stranded in desert sand. If you see RLC on your exam, think large-scale human modification, unintended environmental consequences, political decisions about resource use, terraced agriculture, as seen in the Philippines' Banao rice terraces or the Andes, shows humans reshaping terrain to make it agriculturally viable. This is modification in service of food security, and it's also a powerful example of possibilism. Steep mountain slopes became productive farmland through human ingenuity. Sustainable development is a critical concept here too, because it represents the attempt to balance human needs with environmental preservation. The classic definition from the Brundtland Commission, development that meets the needs of the present without compromising the ability of future generations to meet their own needs, is exactly the kind of phrasing the AP exam may quote or paraphrase. Know it. Connections across units. Human-environment interaction threads through the entire AP Human Geography course, so recognizing it in other units will help you score higher. In Unit 2, population distribution is fundamentally shaped by environmental factors. People cluster where the environment supports life. In Unit 5 on agriculture, every farming system reflects human adaptation to environmental conditions. In Unit 6 on cities, urban heat islands, and flood risk in low-lying neighborhoods are human-environment interactions with major social justice implications that connect back to political ecology. In Unit 7 on industrialization, pollution, and resource depletion are the direct consequences of human modification at scale. On FRQ responses, always be explicit. Don't just say the environment affects farming. Say the semi-arid climate of the Sahel limits agricultural possibilities, but pastoral nomadism represents a possibilist adaptation that works within those constraints. That kind of precision, naming the framework, connecting it to the real example, is what earns rubric points. One last watch-out. Students frequently write that humans are destroying the environment as if that's the only kind of interaction. The AP exam wants you to see the full spectrum: dependence, modification, which can be restoration or degradation, and adaptation. Human-environment interaction is dynamic and multidirectional, and your answers should reflect that complexity. With the conceptual toolkit of this section now in hand, determinism, possibilism, political ecology, scale, modification, and adaptation, you're ready to move forward into looking at how geographers actually collect and represent this kind of spatial information, which is exactly what we'll explore when we turn to the maps, data, and geographic tools that make all of this analysis possible. 1/8 scales of analysis: local, regional, national, global. How scale changes patterns and analysis. What is scale and why does it matter? Let's start with a thought experiment. Imagine you're trying to understand why a particular neighborhood in Chicago has high rates of unemployment. If you zoom way out and look at the global economy, you might conclude that deindustrialization, the worldwide shift away from manufacturing, is the culprit. Zoom in to the national level, and you might point to U.S. trade policy or federal job training programs. Zoom into the regional level, and the story shifts again. Maybe the Rust Belt's collapse of the steel industry matters most here, but zoom all the way into that specific neighborhood, and suddenly you're talking about a lack of nearby public transit, or a single factory closure that took 3,000 jobs with it. Same phenomenon. 4 completely different explanations. That, in a nutshell, is why scale of analysis is one of the most powerful and most tested concepts in AP Human Geography. Scale of analysis refers to the level of geographic detail at which you examine a pattern or process. The College Board recognizes 4 primary scales you must be comfortable working with: local, regional, national, and global. Think of these as 4 different camera lenses you can swap on the same camera. A wide-angle lens captures the whole landscape but loses fine detail. A macro lens reveals incredible detail but loses the broader context. Neither lens is correct. They each reveal different truths. The AP exam will test whether you understand that your conclusions about a geographic pattern can change dramatically depending on which lens you choose. The 4 scales defined. At the local scale, you're examining patterns at the smallest level: a neighborhood, a city block, a single city. This is the most granular view. Local scale analysis is essential when you want to understand hyper-specific patterns, why one side of a street has higher property values, or how a single community responds to a new immigrant population. Local patterns often reflect unique, place-specific factors that disappear when you zoom out. The regional scale sits one step above local. A region is a group of places united by shared characteristics: physical, cultural, economic, or political. This might be the American South, Sub-Saharan Africa, or the European Union. Regional analysis helps you see patterns that transcend individual cities but don't yet apply to an entire country. One classic AP exam trap here: students sometimes confuse regional with national. Remember, a region can cross national borders. The Amazon basin spans 9 countries. Or it can be a subdivision within a single country, like Appalachia within the United States. The national scale looks at the country as the unit of analysis. This is the level where federal policies, national identity, and country-level statistics live. When the United Nations releases data comparing literacy rates or GDP per capita country by country, they're working at the national scale. The national scale is also the level where you examine things like immigration law, census data, and national economic trends. Finally, the global scale is the widest lens of all: patterns and processes that operate across the entire planet. Globalization, climate change, the diffusion of the internet, the COVID-19 pandemic. These are inherently global phenomena. At the global scale, you're looking for patterns that transcend any one country or region, often driven by flows of capital, people, ideas, and goods that cross borders freely. How scale changes patterns and analysis. Here's the single most important idea in this entire section, and the one the AP exam hammers relentlessly. The pattern you observe and the conclusion you draw depend entirely on the scale at which you're looking. This is sometimes called the modifiable areal unit problem. Though the AP exam typically won't use that exact phrase, understanding the concept is essential. When you change the geographic boundaries of your analysis, you can get different results from the same underlying data. Think about income inequality. At the global scale, the richest countries are overwhelmingly concentrated in North America, Western Europe, and parts of East Asia, but zoom to the national scale within the United States, and you find profound regional disparities. Mississippi looks nothing like Connecticut. Zoom to the local scale within Mississippi, and you'll find wealthy enclaves tucked inside counties with some of the highest poverty rates in the nation. The inequality exists at every scale, but its character, causes, and potential solutions look different at each one. For the FRQ portion of the exam, the College Board loves to ask you to explain how the pattern changes at different scales of analysis. When you see this prompt, your scoring rubric move is to explicitly name each scale, describe what the pattern looks like at that scale, and explain why it looks different, connecting it to different causes or processes operating at each level. Don't just say the pattern changes, explain the mechanism. That's where the points live. Common MCQ traps and how to avoid them. The most frequent wrong answer trap on scale MCQs involves conflating the size of the area with the scale of analysis. Students assume that because something covers a large physical territory, it must be a larger scale. This is backwards. In cartography, a large-scale map actually shows a small area in great detail, like a city map. A small-scale map shows a large area with less detail, like a world map. The AP exam will sometimes test this cartographic definition of scale alongside the analytical definition, so know both. If a question asks which map shows the most detail, the answer is the large-scale map, even though it covers less territory. Another trap. assuming that one scale of analysis is inherently more accurate or more useful than another. The exam wants you to understand that all 4 scales are valid and that skilled geographers move fluidly between them. A question might describe a geographer studying deforestation rates and ask which scale is most appropriate. The answer depends entirely on the research question being asked. Local, if they're studying one community's timber harvesting practices. Global, if they're mapping satellite data across all tropical forests. Connections to other units. Scale of analysis isn't a concept that lives only in Unit 1, it threads through every unit in this course. In Unit 2, when you examine population distribution, you'll find that population density looks remarkably different at local versus global scales. In Unit 3, cultural patterns like language and religion show regional clustering that disappears at the global scale and fractures into incredible complexity at the local scale. In Unit 4, political geography is fundamentally about the tension between different scales, local identity versus national sovereignty versus global governance. In Unit 7, economic development data at the national scale, like GNI per capita, can mask enormous local inequality. Whenever you're analyzing any geographic pattern on this exam, ask yourself, at what scale is this analysis being conducted, and how might the answer change if I shifted the scale up or down? Understanding scales of analysis gives you the geographic imagination that ties all of human geography together. And with that foundation firmly in place, you're ready to explore how geographers actually represent the world through maps, which is exactly where we're headed next. 1.9 Regional Analysis and Regional Boundaries. Formal, functional, and perceptual vernacular regions. What is a region, really? Let's start with a question that sounds almost too simple. What makes a place a place? When someone says the South or Silicon Valley or the Corn Belt, they're not just pointing at a dot on a map, they're invoking a whole set of characteristics, relationships, and feelings that give that chunk of Earth's surface meaning. That's exactly what geographers are doing when they define regions. And for the AP exam, you need to understand not just what regions are, but how they work, how they're bounded, and why those boundaries matter. A region is any area of Earth's surface that shares one or more unifying characteristics. That definition sounds clean, but here's the first thing to lock into your memory. The characteristics that unify a region depend entirely on what the geographer is trying to study. Regions are intellectual tools, not objective facts stamped onto the landscape. Keep that idea close. It'll save you on multiple choice questions that try to trick you into thinking one region type is more real than another. Formal regions, the clean lines. Imagine drawing a circle around every county in the United States where corn is the dominant crop. The resulting area, clearly defined, measurable, based on a single quantifiable criterion, is a formal region, sometimes called a uniform region or homogeneous region. Formal regions are defined by one or more shared, measurable characteristics that apply uniformly throughout the area. Political boundaries are the most obvious examples. France is a formal region because every square kilometer within its borders falls under French sovereignty. Climate zones, language regions, soil types, and religion maps are all formal regions too. Here's the critical AP exam nuance. Formal regions always have clear, definable criteria, but their boundaries are not always precise on the ground. A climate zone transitions gradually from humid subtropical to semi-arid. The line on a map is a human decision about where to draw it. On the FRQ, if you're asked to describe the boundaries of a formal region, use language like defined by a specific, measurable criterion, and acknowledge that even formal boundaries can be transitional zones called transition zones or boundary zones. Examiners love when you show that sophistication. Functional regions, following the flows. Now picture a major city, let's say Chicago. Every morning, millions of people commute into that urban core from surrounding suburbs and exurbs. Every evening, they flow back out. The area organized around Chicago by those daily movements, that web of economic and social connections, is a functional region, also called a nodal region. A functional region is defined by its organization around a central point or node with connections flowing outward, and the intensity of those connections decreasing with distance from the node. The go-to examples for AP Human Geography are newspaper circulation areas, cell phone coverage zones, the signal range of a radio or TV station, and metropolitan areas defined by commuter flows. A pizza chain's delivery zone is a functional region. A hospital's service area is a functional region. The key question you're always asking is, what central place organizes this space, and how far do its connections reach? Functional regions have a defining edge concept you need to know cold. The sphere of influence decreases as you move away from the node. This is deeply connected to central place theory from Unit 7 and to the distance decay principle you encounter throughout the course. The outer boundary of a functional region is often called the hinterland, the area that depends on the central node for goods, services, or information. On the exam, if a question describes diminishing newspaper subscriptions as you move away from a city or declining commuter traffic as you move further from a downtown, that's a functional region's boundary in action. Perceptual and vernacular regions. What people believe, here's where things get genuinely fascinating. A perceptual region, also called a vernacular region, is an area that people believe exists as a cultural reality, based on feelings, attitudes, and popular images rather than objective data. These regions live in the mind more than on the map. Think about the South in the United States. Ask 100 people to draw its boundaries and you'll get 100 different maps. Does Texas count? What about southern Missouri? Northern Florida? Nobody agrees because the South is defined by a shared cultural identity, associations with food, music, dialect, history, and attitude, not by a government decree or a climate measurement. Other classic examples include the Middle East. Its boundaries shift dramatically depending on who's drawing the map and why. The Rust Belt, the Bible Belt, and Silicon Valley. Here's the trap the College Board loves to set. Students sometimes dismiss perceptual regions as less important because they're not real. Fight that instinct hard. Perceptual regions have enormous real-world consequences. They shape migration decisions, marketing strategies, political identities, and even conflict. When someone decides to move somewhere because they feel it matches their cultural identity, a perceptual region just influenced a demographic pattern. The AP exam absolutely rewards the understanding that mental maps and perceived regions drive human behavior just as powerfully as physical facts. The big three side by side, and the traps. Let's make sure you can distinguish these instantly. Formal equals measurable and uniform. Think political boundaries, climate zones, language regions. Functional equals organized around a node with flows connecting to it. Think commuter zones, trade areas, media markets. Perceptual equals defined by shared beliefs and cultural identity. Think the Deep South, the Great Plains, or the Midwest. The most common MCQ trap is confusing functional and formal. A metropolitan statistical area defined by the Census Bureau using commuter data looks official and precise, so students call it formal, but it's functional. It's defined by movement and connection to a node, not by uniform characteristics throughout. Always ask yourself, is this region held together by a shared trait or by flows and connections to a center? A second trap involves regional boundaries in general. The AP exam frequently presents regions with overlapping or ambiguous borders and asks you to identify the region type or explain why the boundary is contested. Your answer should almost always acknowledge that regions are constructed by geographers for specific purposes, and that transition zones exist even for formal regions. Connections across the course. Regional analysis threads through every single unit of AP Human Geography. In Unit 2, population distributions form regional patterns. In Unit 3, cultural landscapes define perceptual regions. Unit 4's political geography is built on formal regional boundaries and the tensions that arise when functional or perceptual regions don't match political ones. Think of ethnic groups whose vernacular homeland crosses international borders. Unit 7's urban geography is essentially the study of functional regions organized around cities. Whenever you encounter a free response question asking you to describe patterns or explain spatial organization, The language of formal, functional, and perceptual regions gives you the precise vocabulary that earns rubric points. Understanding how regions are constructed and contested sets you up perfectly for the next layer of geographic thinking, how geographers actually represent and interpret spatial data, and the tools they use to make those regions visible on maps and in models. 1-day, geographic models and limitations. What is a geographic model, really? Let's start with a question. Have you ever used Google Maps to plan a route, only to arrive at your destination and find the road completely different from what the app showed? Maybe there's a new construction detour or a neighborhood that's changed dramatically. That gap between what the map showed and what reality looked like, that's the essence of what we're talking about in this section. Geographic models are simplified representations of reality. They're intellectual maps of how the world works, and like all maps, they leave things out on purpose. Your job on the AP exam is to understand not just what these models say, but why they simplify, what they get right, and crucially, where they fall apart. The College Board defines a model as a simplified representation of reality used to demonstrate an otherwise complex geographic concept or relationship. Notice that word simplified? It's doing a lot of work there. Every model we study in AP Human Geography makes assumptions, often big ones, and those assumptions are what you need to scrutinize. The big models you must know. You're going to encounter geographic models throughout every unit of this course, but this section asks you to think about them as a category. The two you'll most frequently analyze in terms of limitations are the von Thunen model, agricultural land use, and the Burgess concentric zone model, urban structure. Though the principle applies to every model you'll study, including Ravenstein's laws of migration, Wallerstein's world systems theory, and the demographic transition model. Let's use von Thunen as our working example, because it illustrates the concept of model limitations beautifully. Johann Heinrich von Thunen imagined a single, isolated city sitting at the center of a perfectly flat plain with uniform soil, uniform climate, and no rivers or mountains. From that center, he predicted which agricultural activities would occupy which rings based on land costs and transportation costs to market. Dairy farming and vegetables cluster close to the city because they're perishable and expensive to transport. Forests sit in the next ring for lumber. Grain farming comes further out. Ranching is on the outermost edge because cattle can essentially walk themselves to market. Now here's where the exam tests you. When you see a question about von Thunen, it will almost certainly ask you to either apply the model or, and this is the critical skill, evaluate why the real world doesn't match the prediction. Real landscapes have rivers, which reduce transportation costs along their banks and distort the rings into elongated shapes. Real cities are surrounded by other cities, eliminating the isolated state assumption entirely. Technology, especially refrigerated transport, has collapsed distance as a variable for perishable goods. On the FRQ, you can earn scoring points by naming a specific assumption the model makes, then explaining how real-world conditions violate that assumption, then describing the geographic outcome that actually results. Assumptions are the key. Here's the mental framework you want to lock in. Every model rests on a set of assumptions, and every limitation flows directly from one of those assumptions being violated. Think of it like a recipe. If the recipe assumes you have a conventional oven and you only have a microwave, the dish isn't going to turn out the way the recipe predicted, not because the recipe is wrong exactly, but because a foundational assumption wasn't met. The Burgess concentric zone model assumes a city grows outward uniformly in all directions from a central business district, that transportation costs decrease your willingness to pay for land the farther you get from the center, and that social groups naturally sort themselves by wealth, the wealthy moving outward over time as neighborhoods age. This works reasonably well for early 20th century Chicago, where Burgess developed it. It works far less well for Los Angeles, where multiple urban cores exist, or for cities in Latin America and sub-Saharan Africa, which have their own distinct urban morphology models. The Latin American city model is one you should absolutely know. This cross-unit connection is important. When Unit 6 asks you about global urban structure, you'll need to recall that Western models don't transplant universally. The MCQ trap you must avoid. The most common wrong answer trap in MCQs about geographic models is confusing a model's limitation with a model being wrong or useless. The College Board is not testing whether you think models are bad. Models are extraordinarily useful. That's why we use them. The exam is testing whether you understand the relationship between simplifying assumptions and predictive accuracy. If a question says, which of the following best explains why the von Thunen model does not accurately predict agricultural land use in this region, the answer is not, the model is outdated. The answer will always point to a specific violated assumption, the presence of navigable waterways, competing urban markets nearby, or subsidized transportation infrastructure. Another trap, confusing descriptive models with normative ones. Some models describe what exists, others prescribe what should exist or predict what will happen. The demographic transition model, for instance, was originally built on Western European historical data, and treating it as a universal law of development is itself a critical limitation, something that frequently appears in both MCQ and FRQ contexts. Scale and the limits of generalization. Here's a concept that ties this section to Unit 1's broader themes. Scale matters enormously when applying models. A model that accurately predicts land use patterns at the regional scale may be useless at the local scale. The demographic transition model does a reasonable job describing broad patterns across entire nations over centuries, but it tells you very little about birth rates in a specific city or neighborhood. This is the scale problem in geographic modeling, and it's connected directly to what you learned in earlier sections about how geographic analysis changes as you zoom in or out. The FRQ rubric for questions about models will almost always have points available for you identifying the scale at which a model applies, the specific assumption being violated in a case study, and the real-world factor that the model fails to account for. Practice saying to yourself, this model assumes X. In this example, X is not true because of Y. Therefore, the model predicts Z, but reality shows W. Connecting to the whole course, you'll use this critical lens on every model that appears from Unit 2 through Unit 7. When you study the gravity model in migration and trade, you'll ask whether populations are truly comparable and whether all distances are equal. When you study Weber's least cost theory for industrial location, you'll ask whether labor and material costs are actually fixed. When you study Kristoller's central place theory, you'll ask whether consumers really do minimize travel distance to goods and services. The habit of thinking you're building right now, question the assumptions, identify the limitations, apply the model with appropriate skepticism is the single most transferable skill in this entire course. As we move into Unit 2, you'll apply this exact framework to one of the most widely used models in all of AP Human Geography, the demographic transition model, where you'll see both its extraordinary explanatory power and the very real limits of applying a European historical pattern to the diverse development paths of countries around the globe today. 1.11 Quantitative and Qualitative Geographic Data. What are we really talking about? Imagine you're a journalist trying to write a story about a neighborhood that's changing rapidly. You could pull up census data, median income, population density, housing values, and build a compelling picture with numbers. Or you could spend a week walking the streets, talking to residents, photographing storefronts, and recording interviews. Both approaches tell you something real about that neighborhood, but they tell you different things in different ways. That tension right there is the heart of Section 1.1. 11 geographers face this exact choice every time they set out to understand a place, and the College Board wants you to know not just what each type of data is, but when and why geographers use one over the other, and crucially, what each type can and cannot reveal. Quantitative data, the power of numbers. Quantitative data is anything that can be measured and expressed numerically. Think of it as the data you can put into a spreadsheet, run calculations on, and map with precise values. Population counts, elevation measurements, temperature readings, GDP per capita, birth rates, migration flows, all of these are quantitative. The defining feature is that the data is countable or measurable, which means it can be compared, averaged, graphed, and statistically analyzed. On the AP exam, you need to recognize quantitative data in context and understand the tools geographers use to work with it. Choropleth maps, dot density maps, and proportional symbol maps are all visual representations of quantitative data. Each dot or each shaded region represents a specific numerical value. When you see a choropleth map shading countries by fertility rate, that's quantitative data visualized spatially. The College Board loves asking you to interpret these maps, so practice reading the legend carefully and understanding what the gradations actually mean. One formula you absolutely need to know, and the exam tests this directly, is the population density formula. Population density equals total population divided by total land area. Simple enough, but the AP exam often complicates it. Watch for the difference between arithmetic density, total population divided by total land area, physiological density, total population divided by arable land, and agricultural density, total farmers divided by arable land. These three are among the most commonly confused concepts in Unit 2, but they're introduced conceptually right here in Unit 1. Physiological density tells you something, arithmetic density misses. It reflects actual pressure on usable land, which matters enormously in a country like Egypt, where most of the territory is desert. Another key quantitative concept is the natural increase rate, or NIR, birth rate minus death rate, divided by 10 expressed as a percentage. If a country has a birth rate of 30 per thousand and a death rate of 10 per thousand, the NIR is 2%. The exam frequently asks you to calculate this and then connect it to the demographic transition model. So notice how quantitative data and theoretical models talk to each other. Qualitative data, the story numbers can't tell. Now here's where it gets interesting, and where students often undersell this half of the topic on FRQs. Qualitative data is non-numerical. It captures meaning, experience, perception, and context. Think interviews, field observations, photographs, historical documents, personal narratives, mental maps drawn by residents, and oral histories. The defining feature is that it is descriptive rather than measurable. Here's the key insight the College Board wants you to internalize. Qualitative data isn't less rigorous or less scientific. It's designed to answer different questions. Quantitative data can tell you that a neighborhood's median income dropped 40% over 2 decades. But qualitative data, interviews with longtime residents, photographs of changing storefronts, ethnographic observation, can tell you why that happened and what it felt like to live through it. Both are valid. Both are essential to geographic inquiry. Mental maps are a classic qualitative tool that appears on the exam. A mental map is an individual's internal representation of space, how someone pictures their city, their country, or the world based on personal experience and cultural background. These maps are subjective and distorted, and that's the entire point. They reveal how people perceive space, which influences behavior. Someone who perceives their neighborhood as unsafe may avoid certain streets even if crime statistics don't support that fear. The perception shapes the geography of their daily movement. The common traps on the MCQ. Here's where students lose points, so listen carefully. The most common MCQ trap is assuming quantitative data is always better or more objective than qualitative data. The AP exam will present scenarios and ask which data type is most appropriate for a given research question. If the question asks about migration patterns across a region, you want quantitative data, census flows, numerical counts. But if the question asks about why immigrants choose particular destinations or how they experience cultural adaptation, qualitative data, interviews, oral histories is the appropriate tool. Match the data type to the research question, not to some abstract hierarchy of rigor. Another trap involves primary versus secondary sources, which overlaps with this topic. Primary data is collected firsthand by the researcher. You conduct the interview, you take the field observation, you run the survey. Secondary data is collected by someone else and then used by you. Census records, government statistics, previously published studies. Both quantitative and qualitative data can be primary or secondary, and students often conflate these two distinctions. A census is quantitative and secondary. An interview you conduct is qualitative and primary. Keep those axes separate in your mind. How this connects across units. This section isn't just an isolated vocabulary lesson, it's foundational scaffolding for everything that comes after. In Unit 2, every demographic concept you encounter, population pyramids, the demographic transition model, the epidemiological transition model, relies on quantitative data collected through censuses and vital statistics. In Unit 4, when you analyze the cultural landscape, you're doing qualitative geographic work, observing built environments, reading symbolic meaning into architecture and land use. In Unit 7, when geographers debate the causes of development inequality, they triangulate between quantitative indicators like the Human Development Index and qualitative accounts of lived poverty. And in FRQs across every unit, if you can specify what kind of data a geographer would use and why that choice fits the research question, you're hitting rubric points that weaker answers miss entirely. For your FRQ practice, build a habit whenever a prompt asks you to describe a geographic research method or explain how a geographer might study something, explicitly name the data type, explain why it fits the question, and acknowledge what the other type would contribute differently. That level of methodological awareness is exactly what earns full credit. With our data toolkit now in hand, knowing how to measure, count, observe, and interpret the geographic world, we're ready to move into Unit 2, where you'll put all of these skills to work as we examine the patterns and processes of human population across the globe. 1.1 Stewart-Spatial Thinking Skills. Diffusion types, relocation, expansion, contagious, hierarchical, stimulus diffusion. The big idea, how things spread across space. Imagine you're at a concert and someone starts doing a wave. It ripples through the crowd, but here's the thing. The people doing the wave aren't moving to the next section. The idea of the wave is moving. That right there is the essence of what geographers call spatial diffusion, the process by which an idea, innovation, disease, cultural practice, or phenomenon spreads across space and through time. And on the AP exam, your ability to distinguish how that spreading happens is absolutely critical. Let's walk through each type together. Relocation diffusion. Let's start with the most straightforward type. Relocation diffusion occurs when people physically move from one place to another and carry something with them: a language, a religion, a disease, a food tradition. The key word here is movement of people. The thing being diffused travels with its carriers rather than spreading outward from a fixed source. Think about the spread of Buddhism from India into Southeast Asia, or how Spanish became dominant in Latin America. Both cases involved actual human migration carrying cultural traits into new regions. A classic AP-friendly example is the spread of disease among early colonizers. European settlers carried smallpox to the Americas not because the idea of smallpox spread, but because infected people physically relocated there. Here's your trap alert for relocation diffusion. Students often confuse it with expansion, diffusion simply because something is spreading. Ask yourself, are people moving or is the idea moving? If the answer is people are carrying it as they go, that's relocation. The original source location does not necessarily retain the trait. That's another key distinguisher. When European immigrants brought their home country languages to the United States, those languages often diminished back in the source communities over generations. Expansion diffusion, the parent category. Now here's where things get layered, and this is where the AP exam loves to test nuance. Expansion diffusion is the broader category in which a phenomenon spreads outward from a hearth, an original point of innovation while the source area retains the trait. Think of it like a fire spreading from a campfire. The original flame keeps burning even as new flames catch on. All three of the next types, contagious, hierarchical, and stimulus, are subtypes of expansion diffusion. Knowing this hierarchy is itself an FRQ scoring point. Contagious diffusion. Contagious diffusion is the most intuitive subtype. It spreads like a disease, rapidly, widely, and in all directions from the source, moving to nearby places first based on proximity. Distance matters enormously here. The closer you are to the source, the more likely you are to catch the spreading phenomenon. The COVID-19 pandemic is a near-perfect modern example. It spread from its initial epicenters to neighboring communities, then outward, hitting geographically proximate populations earliest. Social media trends work this way too. A meme or viral video spreads from person to person in overlapping networks, not by jumping to celebrities first and trickling down. When you see the phrase spreads to nearby areas, regardless of population size or status, that's your signal: contagious diffusion. Hierarchical diffusion. Hierarchical diffusion flips that logic entirely, and this is one of the exam's favorite contrast pairs. Instead of spreading based on proximity, hierarchical diffusion moves through a ranked system, typically from larger, more influential places to smaller ones, or from people of higher status downward to the general population. Fashion trends are the textbook example here. A designer debuts a look in Paris or Milan. It moves to New York and Tokyo, then to major regional cities, then to mid-sized towns, and finally to rural areas, not because those rural areas are geographically closest to Paris, but because they are lower in the urban hierarchy. Hip-hop music followed a hierarchical path too, emerging in New York City, spreading to other major metros, and eventually reaching smaller markets over time. The AP trap with hierarchical diffusion is assuming that cities must be geographically adjacent. They don't have to be. The pattern is about rank and influence, not physical distance. A trend can jump from New York to Los Angeles before it ever reaches New Jersey, simply because LA ranks higher in the cultural hierarchy. Stimulus diffusion. This is the most conceptually sophisticated type, and it rewards students who understand nuance. Stimulus diffusion occurs when the underlying idea or principle of something spreads, but the specific form adapts or changes to fit the new cultural context. The original innovation is the spark, but what ignites in the new location looks different. McDonald's entering India is the go-to example. The concept of fast food, quick service, standardized menu, brand-driven experience absolutely spread to India. But the Maharaja Mac replaced the beef Big Mac because cultural and religious norms made the original product non-viable. The stimulus, fast food as a concept, diffused. The specific form, the beef burger, did not. Similarly, when Starbucks entered China, the coffeehouse concept spread but adapted heavily to local tea culture and social gathering norms. On the FRQ, if you're asked to identify stimulus diffusion, you need to name both elements, what the original idea was and how the local adaptation differed from it. That two-part explanation is often what earns the full point. Drawing the diagram. For the AP exam, you should be able to sketch a simple diffusion diagram. Draw a central point, the hearth, for contagious diffusion. Draw concentric rings spreading outward evenly in all directions. Similar to ripples on water, for hierarchical diffusion, draw a few large nodes connected to progressively smaller nodes, like an org chart or a branching tree flowing downward. For relocation, diffusion, draw arrows moving away from a source with no remaining connection or glow at the origin. These visual representations have appeared in stimulus-based FRQs and MCQs, and being able to interpret them quickly can save you precious time. Cross-unit connections. Diffusion doesn't live in a vacuum on the AP exam. It threads through nearly every unit. In Unit 2, you'll use these same frameworks to analyze population migration patterns. Unit 3 is saturated with diffusion, the spread of language families, relocation, the spread of universalizing religions, like Christianity and Islam, both relocation and expansion, and the adaptation of global culture to local contexts, stimulus. Unit 7's discussion of industrialization and economic development also leans on hierarchical diffusion, to explain how manufacturing and technology spread from core to periphery nations. Whenever you encounter a phenomenon spreading across space in any unit, reach for this vocabulary. College Board rewards precise, consistent use of geographic terminology throughout the exam. With your diffusion toolkit now sharp and ready, let's zoom out and look at another foundational spatial concept: how geographers measure and represent distance and scale across different types of maps. 1-3, distance decay and time-space compression. The friction of distance, why geography still matters. Let's start with something you already know intuitively. Think about your closest friends. Chances are a lot of them live nearby, in your neighborhood, your school, maybe your town. Now think about how often you interact with your grandparents who live 3 states away versus the neighbor who lives down the street. Without even realizing it, you've been experiencing one of geography's most fundamental principles your entire life: distance decay. Distance decay is the idea that interaction, connection, influence, and the movement of people, goods, and ideas all decrease as distance increases. The farther apart 2 places are, the less they interact. Simple, right? But let's make it precise, because on the AP exam, precision is everything. The formal definition you need to have locked in is this: distance decay is the diminishing interaction between 2 places as the distance between them increases. Think of it like the signal on your Wi-Fi router. Right next to it, you've got blazing fast speeds. Walk to the other end of the house, and suddenly you're buffering. Walk to your neighbor's backyard, and the signal is essentially gone. The interaction, in this case, the Wi-Fi connection, decays with distance. The gravity model, your mathematical best friend. Now here's where we get into the formula that shows up constantly on the AP exam. Geographers quantify distance decay using the gravity model, which is borrowed directly from Newton's law of gravity in physics. The formula is interaction equals population of place A times population of place B divided by distance squared. Read that carefully. The interaction between 2 places is directly proportional to the product of their populations and inversely proportional to the square of the distance between them. Larger cities interact more. Makes sense, but double the distance between them, and interaction doesn't just halve, it drops to 1/4 because you're squaring that distance. That's the critical insight students miss. Distance has a disproportionate dampening effect on interaction. Here's how you'd use this on an FRQ or MCQ. If City A has a population of 500,000 and City B has 200,000 and they're 100 miles apart, their interaction score is 500,000 times 200,000 divided by 100 squared, which gives you million. Now move those cities 200 miles apart, same populations, just double the distance, and you get 100,000,000 divided 40,000 equals 2,500,000. The interaction dropped to 1/4. That's the gravity model doing its job. When you're asked to draw or interpret a distance decay graph, picture this. The x-axis represents distance from a place, and the y-axis represents the level of interaction or the frequency of migration, trade, communication, or whatever the study is measuring. The line starts high on the left and curves steeply downward to the right, a negative exponential curve. It never quite hits 0, but it gets close. That visual, a steep initial drop that gradually flattens, is exactly what you need to be able to sketch and interpret. Time-space compression, when distance shrinks. Now here's where the story gets more interesting, because geography isn't static. The relationship between distance and interaction has been fundamentally transformed by technology, and that transformation has a name: time-space compression. Time-space compression, a concept developed by geographer David Harvey, refers to the way technology has made the world feel smaller by reducing the time it takes to cross distances or communicate across them. The term compression is perfect here. Imagine taking that distance decay curve and physically squeezing it from both sides. Places that used to be far in terms of interaction are now effectively much closer. Think about this historically. In 1800, a letter from New York to London took weeks by ship. That distance was enormous in a functional sense. It severely limited economic ties, cultural exchange, and political coordination. By 1900, the telegraph could send a message in minutes. By 2025, you can video call someone in Tokyo with 0 perceptible delay. The physical distance hasn't changed by a single mile, but the functional distance, the time, cost, and effort required to bridge that gap, has essentially collapsed. That's time-space compression. The AP exam loves asking you to connect time-space compression to globalization, Unit 1 and throughout the course, the spread of culture, Unit 3, international trade patterns, Unit 7, and even urban development, Unit 6. Always ask yourself, What happens to the gravity model when technology reduces the effective distance between places? The answer is that interaction increases dramatically, which is exactly why global cities like New York, London, and Tokyo have become so densely connected despite being thousands of miles apart. Common traps and misconceptions. Here are the traps that catch students on exam day. First, students often confuse distance decay with the idea that distance no longer matters. Time-space compression has reduced the friction of distance, but it has not eliminated it. Distance decay still operates. Local interaction is still stronger than distant interaction even in the internet age. An MCQ might describe a scenario where two nearby towns interact more than two distant cities and ask you to name the principle. The answer is distance decay, not time-space compression. Second, watch out for the gravity model question that changes both population and distance at the same time. Work through the formula methodically rather than guessing directionally. If population doubles and distance doubles, those effects partially cancel each other out. The math is the only reliable guide. Third, students mix up the two concepts' directionality. Distance decay describes how interaction weakens over distance. It's a spatial pattern. Time-space compression describes how technology alters that pattern over time. It's a historical process. One is a description of the world. The other is an explanation of how that description has been changing. Connections across the course. These concepts thread through almost every unit that follows. In Unit 3, you'll see distance decay at work in the contagious versus hierarchical diffusion of cultural innovations. Contagious diffusion, which spreads like a ripple outward from a source, is literally distance decay in action. In Unit 4, political boundaries exist partly because distance decay creates natural zones of influence. In Unit 7, the gravity model is used explicitly to model trade flows between countries. Whenever you see patterns of interaction, migration, trade, or cultural spread, ask yourself whether distance decay and time-space compression are part of the explanation, because more often than not, they are. As you move into the next section, you'll start applying this spatial thinking to one of the most powerful tools in human geography: maps, projections, and the many ways we represent and inevitably distort our world.